Alright, hello everyone, anyone that's new here. This is the A1 Singles tracking test for mock. Obviously, I usually do doubles content, so this might be your first time on the channel. This is the mark scheme and explanations. I'll post the link to the original paper that you should be doing in the description in preparation for your tracking test. It's 50 marks, 1 hour, like your tracking test will be. Just do it in exam conditions whenever for your revision. Remember, these aren't even. I mean, they're not even predictions, so don't take them as predictions. Just take it as practice. Since the things that are coming up here will come up in your test, like the topics, but obviously not the exact questions. You can't predict that. So don't do as this is your only revision. But anyway, let's get straight into it. So first, you had this log question. Obviously, logs are not an easy concept for just starting A-level maths. But we're going to get right into it. So you get the first mark for, I'm going to be explaining this mark, the mark code here. So you get a mark for using any of these log laws. So you move the 2 to the front, or you express 2 as log base 5 of 25. The reason why you know that you have to do this is because for these types of log questions, you have to get both sides in one log, and then you can cancel the logs. So turning 2 into log base 5 of something, that's 25. Then next, you get another mark for using 2 correct log laws, so this mark is only for using one of them. You get this next method mark for using both of them, and then you also need to get your equation without logs, which looks something like this. And then after that, it's pretty trivial. You just solve this equation. Obviously, when you're using your equation solver on your numworks, because obviously I don't think anyone's going to do this manually. You should definitely put in your equation solver and then show either factorizing or using the quadratic formula. And when I say show using the quadratic formula, I mean just write the quadratic formula down and then write the answers. That's enough to kind of show you you've actually used a method there instead of just substituting into your calculator. And then you only get x equals 4 because if x equals 1/9, then this 3x minus 2 will become negative, which means that it won't give a real value because you can't have a log of a negative number. You just have to remember that. So this is a fake solution. So this is the only solution, x equals 4. All right, next question. This is a pretty difficult exponential model question. The one thing that I can guarantee you about this paper is there will be a question on predicting something when the time is 0, or when the model starts, or when the tree starts growing, or something like that. So here you just have to set t to 0 in your model. Next, to find this c value, you had to substitute the values in that it gave you, and then solve. So you get to this point here, and then you would divide by 45, and then take ln of both sides, and then you can the ln and the e cancel. You can move the 14c over using the power rule, and then you would get this answer in the end. And then you have to write out because it doesn't say find the value of c. It says find a complete equation for the model, so you have to write down the equation. Next, on part C, you just have to give any of these answers. It says a suitable answer. It doesn't say it has to be one of these 3, so don't worry if it's not exactly this. As long as you think it's suitable, then it should be fine. I mean, like, they're pretty. It just depends on whoever your examiner is, really, if you get this mark. Alright, next we're going straight, because D is probably the harder one, and you don't need any of the information from D to do E, so I've done E first. So you get a mark for just an attempt to do substituting t equals 9 into the model, and then subtracting t equals 4, because that's what it asks in the question. And then you do that calculation. So this is when you substitute t equals 9, this is substituting t equals 4. Remember to put brackets around. Then you just put in your calculator, and you just say the student's claim is justified because the value that you generated, or that you calculated, is similar to the value that the student said. So the claim is justified. And you get an accuracy mark for the correct answer and a statement. You need this end statement. It doesn't have to be exactly this, but as long as it's something along the lines of, like, he's correct because they're close to each other, it's fine. Alright, for this next part, you get a method mark for just an attempt to solve either one of the values that were given. Yeah, just for an attempt to solve any of the values that were given. You get another method mark for attempting to solve this, and then if you get the right answer, then great. You can get the accuracy marks later. Next, you get Next you get this, and you'll get this value here. So you for these equations you take lns of both sides, like the other question, to get your t values, and then you take them away from each other to get the amount of years. And you also, to get this lost accuracy mark, you have to convert it into years and months, like it says in the question. CAO means correct answer only. You can see that in some mark schemes. And we can move on. Yeah. Right, this is the differentiation question. So part A, we'll give a method mark for just trying to use this area equation here. Just like finding an expression for the area, and then you get an accuracy mark for just rearranging that into the equation that you want in terms of L. Next, you get a method mark for substituting your value of L into the volume equation that you should know to create, because it does talk about the volume in the question. You get a mark for differentiating, and also a mark for, so you get a mark for just attempting to differentiate, even if you got the function wrong. Just to note, if all of these method marks, even if you have the answer completely wrong, if you're doing the right method, then you get these marks. It is just the A1 means accuracy, which means you're not going to get this mark if you have the wrong expression. So same with this mark. If you rearrange but you got the wrong answer, you're not going to get this accuracy mark. So but for here, so you get a dependent method mark, because you need this mark to be able to get this mark for differentiating, and then you get an accuracy mark for the correct expression. Then you get a method mark for setting it equal to 0 and attempting to solve for k, or for x in terms of k. Next, you get a method mark for resubstituting that value in to the original equation to find L, because we're saying that L equal, the student's claim, or whoever it was, their claim was that L equals x. Therefore, we're going to need to try and prove that. And it ends up being this, which simplifies to just make root k over 6 again. And you need your correct value, so you say you also need a statement, so like therefore these equal each other, therefore the x and L must be the same for it to be maximum. Next, proving that it's a maximum, you differentiate again, so you get a method mark for just attempting to do the double derivative, and you have to substitute your even if it's an incorrect value, you have to substitute your value in to get this method mark, and then you get its final accuracy mark for the correct value of d2v over dx squared, and also saying that, oh, it's less than 0, therefore is a maximum value. All right, next question. This is the probability question. So for this first part, the mutually exclusive events is just any pair of these, because they're not involved at all in each other, because they don't even have an intersection point. Next part, we just find these in terms of p, or just like if you can find them, and then you just say that. You use, because it's independent, So you use P equals P of C times P of B equals P of B intersection C, and then do that equation and solve for P, and you get that answer. Next, so this is probably the hardest part. So you have to say that, so P of A given not in B is you take all the things that are in A and then put it over all the things that are in A and not in B. Sorry. Sorry, I might be confusing myself. I haven't done probability in a long while. A given that it's not in B means that you put all the stuff that's in A and not in B over just all the stuff that's not in B, right? That's it. So you put all the stuff that's in both over the stuff that's not in B, because that's your total, and then you can rearrange that for this expression here. You get Q over 0.55, and then you have to do this. You have to say that if you add all the probability, the sum of probabilities always equals 1. In any probability situation, doesn't matter if you're doing like this like Venn diagram stuff or anything else that you're going to learn. So you do this, get Q plus R equals 0.22, and then you say that the maximum value of Q, because it doesn't tell you for the value, it tells you the greatest value of P, A given not in B. Therefore, this the greatest value of q is going to be 0.22, because if q plus r is 0.22, the greatest value of q is just going to be when r is 0, which means q is 0.22, which means you substitute that into here, so you just get 2/5, and that's your answer for p, the maximum value of p a given, not in b. All right, next question, you're just finding r and q using, given that this is 0.5, so you do all the things that are in both over the things that aren't in a, and you get one of these two equations, and then from that you can just substitute, or you can just solve this. Actually, you can just fully solve, and you actually will need to get you only need one of these equations, because then when you get either r or q, you can substitute it back into this equation you got back here to get the other value. And then for the last one marker, you just look at the thing. It's just the things that are in a, that aren't in a, and also is not in b. So it can't be in a, can't be in b, but it has to be in c. So it's just the bit, it's just d and the bit of c that isn't in b. And you add, so that's 0.25 plus 0.08, and yeah, that gives you that. Ignore that last part that just flicked up for a second. So this is the tree diagram question. This is kind of a little like break. The only reason I really put it here is because it is in your topic list, so I did need to include it. It's a pretty easy question, just some GCSE stuff. Not really going to explain much. Oh yeah, I did that backwards accidentally. So this question was a pain to mark because the mark scheme for part A was just ridiculous. It asked you to like resolve. I don't even know what I'm going to explain. It was weird. But anyway, so for the first, so I just drew out the diagram. So it looks pretty complicated, but I'm going to simplify it in a minute. So you have obviously have your r value. You actually don't need to write mu r for reasons I'll explain in a minute. And whenever you have a force like this, you should always draw it. You should always draw forces through objects. You should never draw forces like on objects, because you might mess up the directions of resolving. Because if you were to resolve it like this, then you might not know where to go. So, so instead, you're gonna have to draw it through the block, and then. Yeah, then we can draw a cross diagram. I don't know if they teach you this in singles, but this is a cross diagram. So you just put all the things that are going this way here, all the things that are going this way here, and then the same for everywhere else. So this is a much more simple version of this. And now you can easily see where you want to resolve. So resolving perpendicular to the plane, you get this equation of motion. Resolving parallel to the plane, you get this equation of motion. And then from this top equation, you can just solve to find x, which is seen here, x equals 5g. I've just said that 68.6 is 7g, but you don't need to do that. And then from here, you can substitute the value of x into the second equation, where you can get f equals negative g, or negative 9.8. But because it says the magnitude of the frictional force, and also because you can't actually find the frictional force right now, you can't actually find the frictional force because we don't know the direction of it yet. It just asks for the magnitude, so it's always going to be the positive value, so it's positive 9.8. There should be an n there. Sorry about that. Yeah, so it should be positive, so it's going to be positive 9.8. I just realized I didn't put where you get the marks. Alright, so you're going to get a method mark for just attempting to like resolve either x or the weight. You're going to get another mark for attempting to do your equations of motion, so it's another method mark, and then an accuracy mark for getting f equals 9.8. Yeah, part B is going down the plane, because we've just said that our value of f was, we had f, I modelled f here. I said that f is a frictional force. Oh, also, I didn't clarify this. The reason we're not doing anything to do with mu r is because it asks for the frictional force. It doesn't ask for the coefficient of friction or like whatever. It asks for just the frictional force, which is equal to mu r. So you could replace this f with mu r, but it would just add more variables, so it's a bit more complicated. But what I was saying earlier is that I just randomly guessed. I just said, oh, it's going up the plane. I'm just going to model it as going up the plane, the frictional force. But we've said that because we've calculated the frictional force is negative when we're going up the plane, which obviously it can't be. So actually the frictional force is going down the plane, which means that it's moving down the plane because the frictional force is being applied down the plane. Right. This next part, so the mark scheme wasn't as atrocious for this next part, so I just copied the mark scheme. So you get a method mark for just trying to do an equation of motion, another method mark for actually getting the equation, sorry, an accuracy mark for actually getting the equation of motion, and then resolving perpendicular to the plane, so you get another method mark for attempting to do that. I don't know why they're so much more generous with this section than this first bit, because this first bit is a similar amount of work than this bit. And then next you get this. You already have your R value, so you just substitute that in. Because cos alpha is 4/5, I think, so you can substitute that in, get R equals 4g, therefore F equals 2g. Therefore you can substitute that back into this equation and get your A value, which is that. Right, thank you for watching. Sorry if my explanations are a bit fast, but you can always ask me for help. You can always comment, or do my forms in the description, my new forms. I have tutoring forms and forms to suggest new video ideas or videos that you would want. But I hope to be making more singles videos soon, and obviously continue with my double assignment videos. But yeah, I will see you guys next time. Goodbye.